Long-term memory. We've already referred in a general way to the third memory store, long-term memory, which is perhaps the most interesting of all. On the basis of neurological, experimental, and clinical evidence, most cognitive psychologists think that the storage capacity of long-term memory is virtually unlimited and that it contains a permanent record of everything an individual has learned, although some doubt exists about the latter point. One researcher, Thomas Landauer, estimates the capacity of long-term memory at 10 trillion bits of information. The neurological evidence comes from the work of Wilder Penfield, a Canadian neurosurgeon who operated on more than 1,000 patients who experienced epileptic seizures. To determine the source of the seizures, Penfield electrically stimulated various parts of the brain's surface. During this procedure, many patients reported vivid images of long dormant events from their past. It was as if a neurological videotape had been turned on. The experimental evidence, although less dramatic, is just as interesting, and it too has its origins in the early days of information processing theory. In a typical memory study, such as Tulving and Pearlstone, 1966, participants receive a list of nouns to learn. After giving them ample opportunity to recall as many of the words as possible, researchers provide retrieval cues, for instance, category labels such as clothing, food, or animals. In many cases, those given the cues quickly recall additional items. Experiments on how well people recognize previously seen pictures have produced some startling findings. 36 hours after viewing more than 2,500 pictures, a group of college students correctly identified an average of about 2,250 or 90%. Finally, psychiatrists and psychotherapists have reported many case histories of individuals who have been helped to recall seemingly forgotten events through hypnosis or other techniques. Before we move on to a discussion of how information is organized in long-term memory, let's make sure we understand what the research mentioned in the previous two paragraphs does and does not imply. It does suggest that there is more information in long-term memory than we can get to on a given occasion. How many of you have had the experience of not being able to recall a piece of information that you knew was in long-term memory, only to be able to recall it sometime later? What this research does not suggest, however, is that everything we ever experienced is stored there in something like a photographic or videographic record. As you now know, information that is not noticed or linked with previously learned information never gets beyond the short-term store. What you will learn shortly is that quite a bit of what is stored in long-term memory is different from how it was first learned. In other words, we often operate on the basis of distorted knowledge. Read on to find out why. There's this chart back here. Implications for instruction. How findings about the control processes of short-term memory could influence your teaching. Research finding, recognition involves relating a stimulus to information from long-term memory. The implications, compared with older students, elementary school students have less knowledge stored in long-term memory. Therefore, they need structured learning tasks in which one step leads clearly to the next. Attention is influenced by previous experience stored in long-term memory. We notice what we expect to be important. Teachers should develop techniques for capturing students' attention and convincing them that the information being presented will be important to them. Rehearsal prevents the quick disappearance of information from short-term memory. Most children do not begin to rehearse on their own until about age 7. All children, especially younger ones, can benefit from being taught rehearsal techniques. Organization of material into chunks makes it much easier to remember. Teachers can aid students by presenting material in logical chunks and by showing students how to organize information on their own. Meaningful learning occurs when the learner relates new information to prior ideas and experiences. Teachers should mediate learning by relating new information to students' cultural knowledge and by helping students to learn techniques of self-mediation. Visual imagery is easier to recall than abstractions. Teachers should help students develop learning skills that incorporate visual imagery and other memory-aiding techniques. How information is organized in long-term memory. As you have seen, long-term memory plays an influential role throughout the information processing system. The interests, attitudes, skills, and knowledge of the world that reside there influence what we perceive, how we interpret our perceptions, and whether we process information for short-term or long-term storage. In most instances, retrieval of information from long-term memory is extremely rapid and accurate, like finding a book in a well-run library. Accordingly, we conclude that information in long-term memory must be organized. The nature of this organization is a key area in the study of memory. The insights it provides help to illuminate the encoding and retrieval processes associated with long-term memory. Many cognitive psychologists believe that our store of knowledge in long-term memory is organized in terms of schemata, which is plural for schema, and is related in meaning to Jean Piaget's scheme, the way you look at things. A schema is typically defined as an abstract structure of information. It is abstract because it summarizes information about many different cases or examples of something, and it is structured because it represents how its own informational components are interrelated. Schemata give us expectations about objects and events. Dogs bark, birds fly, students listen to their teachers and study industriously. When our schemata are well formed and a specific event is consistent with our expectation, comprehension occurs. When schemata are poorly structured or absent, learning is slow and uncertain. The following example should make this notion of schemata more understandable. For almost everyone raised in the United States, the word classroom typically calls to mind a scene that includes certain people, teacher and students, objects, desks, whiteboard, books, pencils, rules, attend to the teacher's instructions, stay in the classroom unless given permission to leave, and events, reading, listening, writing, talking, drawing. This is a generalized representation, and some classrooms may contain fewer or more of these characteristics. However, as long as students and teachers share the same basic classroom schema, each will generally know what to expect and how to behave in any classroom. It is when people do not possess an appropriate schema that comprehension, memory, and behavior problems arise. This notion was first investigated during the early 1930s by Sir Frederick Bartlett, an English psychologist. In one experiment, Bartlett had participants read and recall a brief story titled The War of the Ghosts, which was based on North American Indian folklore. Because Bartlett's participants had little knowledge of American Indian culture, they had difficulty accurately recalling the story. They omitted certain details and distorted others. The distortions were particularly interesting because they reflected an attempt to interpret the story in terms of the logic and beliefs of Western culture. Similar studies conducted more recently with other kinds of reading materials have reported similar results. The conclusion that Bartlett and other researchers have drawn is that remembering is not simply a matter of retrieving a true-to-life record of information. People often remember their interpretations or constructions of something read, seen, or heard. In addition, when they experience crucial gaps in memory, they tend to fill in these blanks with logical reconstructions of what they think must have been. People then report these reconstructions as memories of actual events. Why we forget. Forgetting is a fact of life. We all do it, and we'll continue to do it for as long as we live. But before we get into the possible reasons why forgetting occurs, we need to clarify exactly what we mean by that term. Forgetting is the inability, often temporary but possibly permanent, to retrieve previously learned information. That deliberate choice of wording eliminates from consideration a very common experience that is often referred to as forgetting by the average person, failing to recall something that was never learned in the first place. If a student complains that she can't recall what the teacher said in class, it may be because she was busy checking her email or Facebook page. This is an attention motivation problem and not a forgetting problem. So, if experimental neurological and clinical evidence suggest that long-term memory is a limitless, permanent, and organized storehouse of previously learned information, then why do we sometimes have difficulty getting at that information when we want it? If you're looking for one simple answer, sorry, you've come to the wrong place. There are several possible reasons why forgetting occurs. Which explanation best explains a failed recall attempt will depend on the circumstances. Inadequate consolidation. Sometimes forgetting occurs because the material wasn't adequately learned in the first place. When learning new material, many students will try to learn as much of it as possible in as little time as possible. Students call this cramming. Psychologists call it massed practice. Whatever the label, it's a terrible tactic because it typically produces a disorganized and poor quality representation in long-term memory that is hard to retrieve. A better option is to engage in distributed practice. Study and then restudy smaller chunks of material at regular intervals. This is thought to strengthen the representation of the material in memory and to distinguish it from material learned later, a process memory researchers call consolidation. We discuss massed and distributed practice in more detail in Suggestions for Teaching section. Non-meaningful learning. A second reason why forgetting occurs is that the information is so different from anything we already know that we can't connect it to existing knowledge schemes in a meaningful way. Recall of this information is marked by omissions and distortions. A good example of how non-meaningful material negatively affects retrieval from long-term memory is our discussion in the previous section of Frederick Bartlett's research with the War of the Ghosts passage. We suggest ways to deal with this problem in the Suggestion for Teaching sections of this and the next chapter. Few opportunities for retrieval. Our third reason is one you probably don't want to hear. You don't take enough tests as you are learning new material. Yes, we know you don't like tests, but that's because they usually have high stakes attached to them. They're used to determine your grade. But tests, short quizzes, actually can also be used to give you feedback about how well you are learning, and by stimulating you to recall what you learned, strengthen those representations in long-term memory. 2 studies conducted under highly realistic conditions illustrate the power of testing on retention. We're going to describe them in more detail than we usually do so you can use them as a model for your own classroom. The first study was done with 8th grade students studying science. To begin, the teacher assigned a chapter for the students to read at home. The following day, they took a brief multiple-choice quiz in class and received feedback about which items they answered correctly. The teacher then conducted a lesson on the content of the chapter. This was immediately followed by a second quiz, again, with feedback about the correctness of their responses. About 3 weeks later, a final quiz with feedback was given. The following day, a unit exam was given. The students also took an end-of-semester exam and an end-of-year exam. To test the effects of the quizzes, half of the items that were on the unit, end-of-semester, and end-of-year exams had appeared previously on the quizzes, and half of the items were new. There were 2 main findings. First, there was a significant increase in the 3 quiz scores, 58, 83, and 86% respectively. Second, students answered more of the previously quizzed items correctly than they did the non-quizzed items. On the unit test, for example, 92% of the quizzed items were answered correctly, compared with 79% of the non-quizzed items. In terms of letter grades, this was the difference between a C plus and an A minus. The differences for the end of semester exam, 79% for previously quizzed items versus 72% for non-quizzed items, and the end of year exam, 68% versus 62%, were smaller but still significant. The second study was done with 6th grade students learning social studies. The design of this study was similar to that of the first study. There was an initial quiz, the teacher's lesson, a second quiz, a 2-day delay followed by a third quiz, a 2-week delay followed by free recall and multiple choice chapter exams, and a 1 to 2 month delay followed by an end of semester exam. Once again, there was a significant increase from the first quiz to the second and third quizzes, 41, 93, and 93, respectively. And scores for the previously quizzed items on the free recall chapter exam, 30%, multiple choice chapter exam, 94%, and end of semester exam, 79%, were higher than for the non-quizzed items, 20% instead of 30, 81 instead of 94, and 67 instead of 79. The researchers then repeated the study with an additional feature that would allow them to rule out the possibility that the increase was due just to seeing the same material 3 times. This time, the 3 quizzes included factual statements mixed in with the multiple choice questions. The results were basically the same. On the chapter and end of semester exam, scores were higher for previously quizzed items than they were for items that were read and non-quizzed items. Interference from other material. To be a student means having to cope with a constant stream of learning material. Inevitably, we encounter ideas that are similar to those we learned earlier, but that call for different responses. In such cases, interference from material learned earlier or later, whether it was learned in school or out, can make it difficult to come up with the correct response. This happens quite frequently in learning a foreign language. Vocabulary, because words that look alike mean different things. Take, for example, the French words for hair, chevaux, and horse, cheval. Students frequently make the wrong choice because of the similarity in spelling. Another example is when a teacher tries to learn the names of a new group of students at the beginning of the year and calls some of them, at least for a while, by the names of the students in the previous class. Lack of retrieval cues. Our last explanation concerns the availability of retrieval cues. A retrieval cue can be any information, such as a word, phrase, image, sound, etc., that is associated with the learned material. Learning does not take place in a vacuum. It occurs in a specific context that includes aspects of the physical environment, characteristics of the learning material, and associated thoughts. Let's say that as you read this chapter, you also take notes of the headings and subheadings and create analogies, like thinking of short-term memory as a funnel that is 7 chunks wide. If that additional information is present when you want to recall the chapter's content, either because it's given to you, or you can generate it yourself, you're more likely to recall the target information. This is known as the encoding specificity principle. Retrieval is more likely to be successful when material that was part of the original encoding is present at the time of recall. The power of retrieval cues is such that one researcher said if the right retrieval cue does not come along, the corresponding memory trace might as well not even be there, as it will never be retrieved again.